Today we start basic topics of complex analysis. One of the important topics, the algebra of complex number. We start today. This one is an important topic. Also we discuss one great book, and obviously this book is very familiar or famous book because of the writer is famous. Lars V. Alford's Complex Analysis, one of the complete textbook. We also read then this one if we understand complex analysis better. Okay, so today we start from the algebra of complex number. Okay, so we start now. We're first going to some arithmetic operation. Okay, first we're going to some arithmetic operation. We know about that any operation which that gives some then some operates two or more quantity of this number, that means here complex number, then this produce some result. Okay, operator, some we know about in previous class of algebra. This one, if star is operator, then if two or more quantity is operates by this operator, then we form or we get one another number. Okay, or another quantity. So that's things now we use here. Okay, what we use here, we also note about that complex number also denoted by which number. Why complex number is from? Because we know about in previous class x square equal to -1. How we do it? We do it in simple way. X equal to I, we denote it in one complex identity or complex number I, then obviously I square equal to -1. Okay, in this way we form complex number. Now we start about that. We start about how a complex number form. We know about that real number is alpha, beta, gamma. This one is real number, obviously in belonging to real life. Now how complex number form? If we draw this two axis here, we denote it real axis, and this one we will denote it imaginary axis. Okay, then some origin obviously belong here, some origin obviously belong here, origin is done, there are two axes is made here. Okay, then say here origin is present. Next we're going to further discussion about that how this one is represented. This one denoted by 1, this one denoted by 1, this one denoted by I, this one denoted by 1. Then how this one is point xy. Okay, this represent a complex number system. Then this point xy is denoted by in this way, so simple way, xy equal to x plus iy. Okay, that means so simple way, x multiplied by y multiplied by I, because this one is I is unit, this one is 1 is unit. So we write in any complex number in this form, x multiplied by 1 and y multiplied by I. Okay, next if alpha beta, we write it alpha plus I beta. This one is a complex number, we write it belongs to C. This one obviously belongs to C. Okay, then we denote this complex number. If here beta equal to 0, we put beta equal to 0, then this one is just alpha, obviously belongs to C, and we call it obviously this one is a real number, alpha belongs to R. Okay, then this one is purely real, that means just real. And if alpha equal to 0, we put alpha equal to 0, then beta I beta is this number is purely imaginary. Okay, this number is which one? Purely imaginary number. Next we denote what? Next we denote two complex number are equal when two complex number are equal. Okay, we write it now. Alpha plus I beta one complex number and gamma plus I delta is complex number when these two numbers is equal. Okay, we conclude here alpha minus gamma plus I beta minus delta equal to 0 plus I 0. Okay, so simple. 0 we from it I 0 multiplied by I 0. So what we find so simple way we compare this two quantity of both sides of equal. How we compare real quantity with real one and complex quantity, that means complex coefficient quantity with complex one. Then what we find this one alpha minus gamma equal to 0 and here beta minus delta equal to 0. Then what we get alpha equal to gamma, beta equal to delta. Okay, then when two complex number are equal, when two complex number are equal, if their real part are equal and complex part or imaginary part are equal, then same real part and same imaginary part having, if having two complex number have same real part and same imaginary part, then these complex numbers are, or these complex numbers are equal. Okay, or if two or more this have same real number and same same real coefficient and same complex coefficient, then we also call those numbers are equal number. Okay, next is this portion. Now we further going to this arithmetic operation. We know about that operate some, that means operation is how we operation see about in our eyes. We see about addition, subtraction, multiplication, division and other operation also from we know about. If we handle algebra, group theory and more theory, then here we denote some that means, so we create some operator and operate two elements. Okay, but here we're not more that means more deeply going to this type of operator, but we just discuss about addition operator, how added that means two complex number is added. Okay, how these two complex number added? We write it so simply: alpha plus I beta one complex number and gamma plus I delta one complex number. These two complex number how added? This one is so simply we write about it: alpha plus gamma plus I beta plus delta. That means real part plus real part and imaginary part plus imaginary part. These two are added. Okay, that means in this way we handle two complex number addition. If you have more, then same thing, we added this real part of more quantity and we added imaginary part of more quantity or more complex number, then we get this result, and this result are the sum of those complex numbers. Okay, next we're going to further discussion about, we obviously discuss about additive operator. This one is, we always call it sum or addition, but this one is in famous mathematics term, this one is additive operator. Okay, this one obviously one operator. Next we're going to done something. This one is alpha plus I beta multiplied by gamma plus I delta. This one is just multiplication operator. Okay, that means how we multiply these two complex number by some operator. Okay, how? This one is so simply we do it, we do just this one, we multiply it first, we multiply it and then we check it. How this real number is multiplied? This one alpha gamma, this one I beta gamma plus this one I alpha delta, this one I square beta delta. So simply we know about that. We write here alpha gamma here plus I common, beta gamma plus alpha delta plus I square equal to how much? I square equal to minus 1 beta delta. Okay, Then this one is alpha gamma minus beta delta. This one is I beta gamma plus alpha delta. So simply we write it. Okay, then what we find? We find this one is two complex number multiplication result. How we obtain? We obtain so simply we multiplied both each other and then separate those real part and imaginary part. But we're going to further. If we write here in another complex number, then this one is done by in this way. That means here we just check about it. This one is first part, this one is first part, this one is second part, this one is second part. That means in real number, in real part, which one from alpha gamma, that means first part multiplied by those here first part, or real part multiplied by real part, and complex part multiplied by complex part, and just minus is belongs between them. And then this one is from real part of the multiplicative number. Next, how we form the imaginary part? This one so simple, just this one is imaginary part multiplied by another real part, and here this imaginary part multiplied by another real part. Okay, then what we find? We find that here beta gamma and plus alpha delta. So in this way we obtain this multiplication of two complex number. That means multiplicative operator, how we handle, we also do by this problem. Okay, next we're going to further discussion about some complex number. That means this one is too easy, but obviously we do it. Okay, here we write 1 plus 2i, here we write minus 1 plus 7i. Then what we do this operator, that means plus operator or additive operator or addition operator, which gives this gives is 1 plus minus 1 plus I multiplied by 2 plus 7. This implies that 0 plus 99. This implies that 99. Okay, next what we get? We get if multiplied those two numbers, this one multiplied by minus 1 plus 7. Then this one is so simple, we're just taking rule, not give more steps by simply calculation of multiplication. So what we do just 1 multiplied by minus 1 minus 2 multiplied by 7 plus I multiplied by 2 multiplied by minus 1 plus 7 multiplied by 1. Okay, then what do we obtain? We obtain here minus 1 minus 14, this one 7 to 14. Okay, and here plus I equal to minus 2 plus 7. Then this one which result from this one equal to minus 15 I here 5. Okay, that means here minus 15 plus 5i. This one is the required or obtained result of this multiplication. We also give some example, and obviously all are created some example. This one is better for understanding. Now we're going to further proceed deal of one operator. Okay, we're also going to operator, additive operator and multiplicative operator. Obviously we here discuss about some another operator, how these operators are handled. That means if subtraction operator and division operator, how these operators are handled, also we going to discuss about that for complex number. Okay, next if here x plus iy difference z minus z plus ip. Okay, this one, that means just just subtraction operator. Then what we find? We find so simple way, in this way, just this one. Okay, that means real part difference real part, imaginary part difference imaginary part, and just have a right eye in front of imaginary part. Next we're going to further discussion about which operator. We know about the division operator, or obviously how we find one, that means inverse operator. Okay, this one is so simple but we have to handle about it. Okay, now we write here alpha plus r beta divisible by gamma plus r delta. What this gives? Okay, this gives obviously a complex number, we know about that, but how this one is done? When this one is exists, so simple way, this one is exists if alpha plus gamma delta not equal to 0, because we know about that division is possible when division is possible if denominator not equal to 0. This one is crucial point, and obviously we know about it, but we just mention here for better understanding. Next we denotate y, this one equal to x plus iy. Then what we find? And then oh no, we not write in lower portion, we write here this one equal to x plus iy. Okay, well, let this one is possible, and here we write gamma plus I delta not equal to 0. Then what we find? We find so easily this one alpha plus I beta multiplied by x plus iy multiplied by gamma plus I delta. Then what we find? We find this rule. This one is x iy minus y x. Oh, here some obstacle is formed. Oh, not a problem at all. Here x gamma and y is not needed. Here we tried z. Okay, z is better because gamma and y is exactly same each other. So just that means just write it gamma x gamma and here z delta. That means we change this y onto z. Okay, next here we write I z y plus x delta. Then what we find? We find equating those real part and complex part of both sides. We get x comma minus z delta equal to alpha, and here z comma plus x delta equal to beta. Next what we get? Then we have to, that means we have to known about that x equal to how much and z equal to how much. Then what we that means we do it so simple calculation of these two equation. This equation is marked at number 1, this equation is marked at number 2. Then we just simple calculate. Okay, how we calculate it? We calculate it here, we calculate x first. Here x is gamma and here delta. Then what we done? We done here we multiplied 1 multiplied by here obviously gamma. Okay, and then added 2 multiplied by delta. Then what we find? We write here, just add this portion, then x gamma square minus z gamma delta plus z gamma delta plus x delta square equal to alpha gamma plus beta delta. Then what we find? We find too easily this one cancel, but not cancel is better. Just we check about that this one are same, so plus and minus gives 0 result. Okay, then what we do? we do x common, gamma square plus delta square equal to alpha gamma plus beta delta. Then what we find? We find x equal to alpha gamma plus beta delta by gamma square plus delta square. That means first one we do it. First one we do it. Next what we find? We find just x equal to we do, and now we find z equal to how much. Then what we found, how we find? We put x equal to in equation 1, then we find z equal to how much. That means here we write z delta equal to x gamma minus alpha. X equal to how much? Alpha gamma plus beta delta multiplied by gamma by gamma square plus delta square minus alpha. Okay, then what we find? We find so simply we write it above portion, we erase this above portion here. Okay, then what we get? We get so simply z delta equal to alpha gamma square plus beta gamma delta minus alpha gamma square minus alpha delta square by gamma square delta square. So what we obtain? This one is 0. Then we get beta gamma delta minus alpha delta square by gamma square delta square. Okay, then what do we get? Then we get z equal to, where is this portion, and we write z equal to how much? Z equal to, if delta not equal to 0, then this one beta gamma minus alpha delta by gamma square plus delta square. Okay, then what we find? We find this one is not 0, and obviously we find this result. This result we write now. This result is so simply alpha plus I beta by gamma plus I delta. That means this two division result, division of these two complex numbers result. Okay, that means this one equal to alpha gamma plus beta delta divided by gamma square plus delta square plus I multiplied by beta gamma minus alpha delta by gamma square plus delta square. So simply we calculate these two, and then we get this result. Okay, final result of division of two complex number. Division, we call it division operator because so simply we do it and sum in this way, but this one is an operator. Okay, this operator handles this rule and we get some result. So what we find? We find so easily that here alpha equal to alpha plus I beta by gamma plus I delta equal to alpha gamma plus beta delta by gamma square plus delta square plus I multiplied by beta gamma minus alpha delta by gamma square plus delta square. Too easily we handle about it, but if we remind it in this way then better. If not in this way, then done this previous calculation. Okay, that means just multiplied by alpha gamma plus beta delta for real part and added those, and alpha delta and beta gamma for complex part and subtract those. Then I is present and divided by gamma square plus delta square. Now we're going to further of one complex number, reciprocal or inverse. How we handle reciprocal or inverse of any complex number. That means if we write 1 by alpha plus I beta, then here we not write properly alpha plus I beta. First we write 1 plus 1 I plus delta. Then here we put alpha equal to 1, beta equal to 0, gamma and delta exactly same. Then what we get? We get so easily that here alpha equal to 1, that means gamma present, and beta 0 complete, gamma by gamma square plus delta square, and in this way which one present? Here minus delta by gamma square plus delta square. Okay, then what we find? We find gamma minus I delta by gamma square plus delta square. This one is the result of 1 by gamma plus delta I delta. Obviously this one is needed. Gamma plus I delta not equal to 0, then this one happen. So we find one inverse of any complex number. How this one is possible? Just gamma minus r delta by gamma square plus delta square. And next we denoted by I to the power n. We know about I and I square also. I one complex number, and I square denoted by -1, and I cube denoted by I. Okay, no, sorry, minus I, because I square multiplied by I, then minus I, and I to the power 4 denoted by I square multiplied by I square equal to -1 multiplied by -1 equal to 1. Then I square, I cube, I4. We present these four numbers. How we obtain? We obviously write it, but we going to further discussion about that. Then we find this one is obviously crucial and important. Okay, so now we're going to another portion, but today we discuss so important results about that. Okay, so important results about that. So here we stop today.